Okay. Now ignore this in the green. This is the last thing we do. Never know how things are going to develop during a class. I never know exactly where things are going to go. It kind of depends where the class leads me. And that's no excuse for poorly organizing the board, but that's actually the reason. Okay. Laws of exponents. Let's just look here. 2 to the third times 2 to the fifth is what? Well, 2 to the third is 2 times 2 times 2. 2 to the fifth is 2 times 2 times 2 times 2 times 2. If we multiply 2 to the third by 2 to the fifth, then we're multiplying this by this, and that means we're going to have 8 2's here, so this comes out to be 2 to the 8th. This is a simple illustration then of why 2 to the third times 2 to the fifth equals 2 to the 3 plus 5. We add these exponents because we add the number of 2's you multiply here to the number of 2's you multiply here to get the total number of 2's you're multiplying. So 2 to the third times 2 to the fifth is 2 to the 3 plus 5, which of course is 2 to the 8th. In general, the rule is b to the x times b to the y equals b to the x plus y. So we write that as a rule here, and you should recognize this as a law of exponents that you've used and known in the past. Really would hopefully still know, because you can always do this kind of a simple example to remind yourself of how those exponents combine. Similarly, 2 to the second to the third. Okay, well, 2 to the second means 2 times 2. So 2 to the second to the third is 2 times 2 to the third. And since taking something to the third power means multiplying it that many times, this is going to be then 2 times 2 times 2 times 2 times 2 times 2. Now, we have 3 groups of 2 2's. How many 2's do we have? 2 times 3 or 6. So we have 2 raised to the 2 times 3 or 2 to the 6. We conclude then that 2 to the second to the third is 2 raised to the 2 times 3. And then we extend that to a rule like b to the x raised to the c equals b to the x times c, or just b to the cx, depending on how you want to write it. And then we write that rule here. So these are two laws of exponents that are very closely related to some really important laws of logarithms. Before I get to that, what if you had this logarithmic equation here? Now, I'm not going to talk about how we get to the next step until we talk about this and do an example, but what if you had this logarithmic equation? What could you do? This is not in the form log to the base of something else equals some other number. It's not in the form that we're used to, or hopefully are used to at this point. Turns out that by turning these laws of exponents around into laws of logarithms, we get a rule that allows us to combine it and get this into an equation that is easy to solve. Now we'll see the details of that, but let's talk about the rules. Okay, if I multiply two numbers with the same base, I can add the exponents, okay? It follows, and I'm not going to explain how or why at this point, it follows, though, that log to the base b of a product of two numbers, and we write that as log base b of mn, is the sum of the logs of m and n to the same base. This is just the flip side of this rule. We might or might not get into a deeper explanation of that, but we do have this rule, and this rule is going to be very handy in solving an equation. That's exactly what I used to solve this equation, or at least to get the equation into the form that we can solve. Another rule that I didn't have to use up here, but will in a number of equations, is log to the base b of m raised to some power n is just n times log to the base b of m. And that's the flip side of the rule that says if you raise a number, b to the x raised to a power c, you get b raised to the product of those two powers. Now, as an example of the first rule, and that's the only one we're really going to look closely at today in class, tomorrow in the regular course, we're going to do many examples of application of these rules so we get more broadly able to solve exponential and logarithmic equations. Okay, but right now we're just going to look at an example of this first rule. Log to the base 2 of 4 times 8. Well, that would be log base 2 of 4 times 8. M would be 4, N would be 8. So that's going to have to equal log to the base 2 of M, which is log to the base 2 of 4, plus log to the base 2 of N, which is log to the base 2 of 8. Now, here we saw that 16 is a power of 2, so we can easily find the log of 16. Similarly, we can easily find the log of base 2 of 4. The log of base 2 of 4 is 2. Why? Because the second power of 2 is equal to 4. That's where the 2 comes from. And the third power of 2 is 8, so the log base 2 of 8 is 3. So we get 2 plus 3 equals 5. Now, if you wanted to key in log base 2 of 4, log of 4 divided by log of 2, log of 8 divided by log of 2, you would get to 2 and 3 without having to turn the expression around in its exponential form. Now, so log of whatever 4 times 8 is should be 5. Of course, 4 times 8 is 32. Is log base 2 of 32 equal to 5? Well, yeah, it is. Simplest reason is because 2 to the 5th is 32. Okay? But of course you could key it into your calculator. But by understanding the details of this, you get a little better understanding of this rule. Now, we apply the same rule to this equation. Now, what we have on the left here is the sum of two logs with the same base. Well, the sum of two logs with the same base is just the log of the product of those things. That's what this rule says. We have log of m to the with the base b and log of n base b, and we're adding those. That means this is log base b of m times n. Meaning that the left-hand side in is then log base 2 of this times this, x times 2x minus 4. And if that's equal to 4, well, it's still equal to 4. Then we just use the rule that we are hopefully very much used to by now and turn this equation around into its exponential form. 2 to the 4th equals x times 2x minus 4. So we have, well, 2 to the 4th is 16, so this x times 2x minus 4 is 16, and we can solve this equation now for x. What kind of an equation is this? It's a quadratic equation, because when you multiply this out, you have 2x squared minus 4x minus 16 equals 0. So rearrange it, multiply everything out, and you get one of these. And now it's much easier than this, because you don't have this log thing, which really isn't all that bad, but you don't have this thing to carry through. You just got plain old numbers. A is 2, B is negative 4, and C is negative 16. So you can easily solve the equation using the quadratic formula. Or if you can find a way to factor it, you can solve it that way. But this one, I don't believe is going to be cooperative if you try to factor it. Okay, so for the class, we're going to end up doing a lot of simplifications using this rule and this rule, applying it to equations so that we can solve the equations.